Okay, so what is all this? What is this mess here? This is what's called sigma notation. It's basically just some fancy notation that's going to talk about the same stuff we talked about in example 4. Um, that is a Greek symbol that represents sum, all right, meaning add it all up. So here's an expression. If it's asking for like what's the sum of all, it's basically you're going to have 9 different numbers, 1 through 9, getting substituted in for I, and you add them all up. All right, so that's what you're going to see here. You might be asking yourself, why didn't I just use the sum formula that we used in example 4? And the answer is we're about to. Okay, so that is how you would do it all by hand. Again, just substitute 1 through 9 in. You get your answers for each of those 9 expressions, and then you add them all up. That is the sum. So that sigma notation represents 36. All right, let's look at the next example. All right, so how can you write that series of numbers using sigma notation? All right, so the first thing you got to do is figure out how many terms are in that sequence, because you don't know. And I guess you could work it out by hand. You can also work it out algebraically. We're going to use the explicit formula. 79 is the last term. 2 is the first term. 7 is the common difference. So we're going to multiply that by n minus 1. And n minus 1, well, we're solving for n, right? So to solve for n, you end up with n equals 12. That means 79 is the 12th term of the sequence, which means there's 12 terms in the series. You can write out the explicit formula. That's going to be able to give you the expression you're going to use in sigma notation. So 2 is the first term, 7 is the common difference. Distribute the 7, you get 7n minus 7. Negative 7 plus 2 is that negative 5. So 7n minus 5 is going to be the notation you use in or the expression you use in sigma notation. So here it is all put together. I equals 1 goes to the bottom, meaning you're starting at 1 for the first term. There are 12 terms in the sequence. The expression you're using is 7i minus 5. So if we want to find the sum of the whole series, let's use the formula we used in example 4. 12 is the amount of terms in the sequence. 2 is the first term. 79 is the last term. All right. You simplify that expression, you get 486. So in conclusion, that's the sigma notation for that set of numbers, series of numbers that you saw. And then 486 is the sum of all of them. All right, so pause it, and then let's try a couple of these questions, and then you can hit play, and then see if your answers match. All right, so what is the sum of this series? Well, we got to figure out a couple things. What's the first term? Well, let's write out the formula. So it's n times a sub 1 plus a sub n, all divided by 2. All right, well, n is 13. A sub 1, well, let's figure it out, right? A sub 1 is equal to 3 times 1 plus 2. 3 plus 1 is 5. 3 times 1 is 5. 3 times 1 is 3 plus 2 is 5. So 5 will go in for a sub 1. What is a sub n? It's 3 times, well, 13, and then plus 2. So 3 times 13 is 39, plus 2 is 41. And then all of that divided by 2. And for simplifying that, 5 plus 41 is 46. Divide 46 by 2 and you get 23. let's see, 13 times 23, real quick, 10 times 23 is 230. 3 times 23 is 69, so you get 299. So believe it or not, you can do math without a calculator. So 299 will be your answer there. Let's check it so I can erase that work before I do the next one. All right, so that does work out. All right, so then let's erase and do the next one. All right, how can you write that series using sigma notation? Then what is the sum? So we need to figure out how many terms are in the sequence. So 43 is the last term. The first term is 8. Common difference is 5. And we need to solve for n. That'll tell us what term in the sequence is 43, which is the last term. So that'll tell us how many terms there are. So the first thing I'll do is subtract the 8, and you get 35. I can divide by 5, and you get 7 is equal to n minus 1. Add 1, and you get n is equal to 8. So now we know there's 8 terms in the sequence. Now we can use the sum formula to figure it all out. So that's the n, which is 8, times the first term, which is also 8, coincidentally, and then plus the last term, which is 43. And then all of that divided by 2. All right, so then 8 divided by 2 is 4, times 51, and you end up with 204. All right, let's see if that worked out. All right. Oh, I didn't write the sigma notation. Well, the only thing I guess I would have needed to do is to figure out the 5i plus 3. So let's do that real quick. So we already knew there was 8 terms in the sequence. So how do I get the 5i plus 3? Well, a sub n is equal to the first term, which is 8, plus 5, which is the common difference, times n minus 1. Just simplify this expression now. So you have 8 plus 5n minus 5. Combine the 8 and the negative 5, and you get 5n plus 3. All right. Well, so just I instead of n. All right. Let's try the last example now.